All right, ladies and gentlemen, so today we're going to be looking at how I can solve these systems, right, two or more equations, using algebra, all right? So there's two different ways that we can do this. The first one is called substitution. Substitution is easiest to use if one of the variables has a, has a coefficient of 1. And remember, if it has a coefficient of 1, and I abbreviated coefficient, if it has a coefficient of 1, it means it's just not written down, but you're still going to see the variable there. So in order to do this, we're going to solve one of the equations for one of the variables. They're usually x and y, but it can really be anything. So you're going to have either x equals or y equals. Then you're going to substitute that expression into the other equation. Right? And again, we're going to kind of go through and look at this too. Solve the resulting equation for x or whatever variable. There should only be x in the equation, or whatever variable it is you chose to do. Then you're going to find the value of y, or the other half. By substituting x into either one of the equations. Check your solution algebraically. 2 answers means 2 checks. Right? You have to be able to do 2 checks. Remembering when we did equations from before that there are times when you have no solution, which is the empty set, or you have variables that cancel on the same side and you have all infinite solutions. All right, so let's take a look at this. So here's an example. We have x plus y equals 1 and x plus 3y equals 9. So what I want to try to do is I want this to either say x equals or y equals. And I can start, I'm going to start with the first equation just because they both have coefficients of 1. So I'm going to start and I'm going to take this and I'm going to solve it so that it says x equals. So I'm going to subtract y, and you could do it the other way. So I know then that x has to be negative y plus 1. Right, we've done that before. So now what I'm going to do is I'm going to take this and I'm going to put it in to that equation. So instead of y, I'm going to substitute in. So I'm going to keep x right here, but now I'm going to have 3. Oh my gosh, I did that wrong. All right, we're just going to erase. I put it in the wrong spot, sorry. I'm going to put this in for where I see x. So I'm going to have negative y plus 1 plus 3y equals 9. Sorry about that, guys. It's an early morning. Okay, so now I go through and solve just like I've done before. So negative y plus 3y is 2y plus 1 equals 9. Subtract 1. So 2y equals 8. Divide both sides by 2. And we get y equals 4. So we have one part of the equation. Now I have to take this 4 and I have to put it into either of my original equations to figure out what x is. And it doesn't matter which one you do. So I'm going to do, I'm just going to pick the first one. So x plus y equals 1. We now know that y is 4. So x plus 4 equals 1. Subtract 4. So we're getting x is negative 3. Now remember, these are points on a graph. So what we just figured out is that my point of intersection, if I had graphed them, was negative 3, 4. All right, so we have to do checks, and you check them into both equations. So x plus y equals 1, and I'm going to fill in negative 3 plus 4. Does negative 3 plus 4 really equals 1? Yes, it checks. And yes, you have to show that last line. I know it seems silly, but you have to. And then we have x plus 3y equals 9. And I'm going to fill in negative 3 plus 3 times 4. 3 times 4 is 12. And negative 3 plus 12 is 9. So it does check. All right, let's try another one. Turn the page. So here I have 3x plus y equals 13 and x plus 6y equals negative 7. I'm going to start with the first equation. Just there's no reason why I couldn't start with the second. I'm just choosing that one. So I'm going to take this equation and I want it to have y by itself. So I'm going to take 3x plus y equals 13, and I'm going to subtract 3x. So y equals negative 3x plus 13. I then take this and I put it into the second equation where y is. So then I'm going to have x plus 6 times negative 3x plus 13 equals negative 7. This I now know how to solve. I have to do my parentheses first. 6 times negative 3 is negative 18. 6 times 13 is 78. Combine your like terms. So we're going to have negative 17x plus 78 equals negative 7. Subtract 78. Negative 17x equals negative 85. Divide, I'm not going to show that just because I ran out of room. Divide both sides by negative 17, and you're going to get x equals 5. All right? Then we're going to put that into, again, either one of the equations. I don't care which one you put it into. I usually take the first one just because it's written first. So 3x plus y equals 13. I now know that x is 5. So 3 times 5 plus y equals 13. 15 plus y. Subtract 15, so y is negative 2. So that means my point would have been 5, negative 2. This then has to get checked. All right, so my check. All right, so we start with the first one, 3x plus y equals 13. We're going to fill in x and y. 3 times 5 plus negative 2. 15 plus negative 2. 13 equals 13. So it worked in the first equation. Then we're going to do it for the second. And we have 5 plus 6 times negative 2. 5 plus negative 12. So negative 7 equals negative 7. So it checked. So that is your correct answer. All right, we're going to try a word problem. We're going to spend more time on word problems in lesson 4, I believe it is. But we're going to start looking at these. So Max and his father Kirk are comparing their ages. They know that the sum of their ages is 52 and that Kirk is 7 years older than 4 times Max's age. So they want us to write this as a system. So if you have two different variables, you have to have two different equations. So we want M to be Max and K to be Kirk. So we know, it says right here, the sum of their ages is 52. M plus K has to be 52. All right, we know that Kirk, K, is 7 years older, 7 years plus 4 times Max's age. So there are your two equations that you have to solve. Okay, well this one already has K by itself, so I can take this, 7 plus 4M, and put it into the first equation. So I don't even have to get anything by itself, which makes life really nice. So M plus 7 plus 4M equals 52, right? I just took out K, I put in 7 plus 4M. These are going to give me 5M plus 7 equals 52, subtract 7. So 5M is 45, divided by 5. So we know then that Max is 9. All right, well now I have to figure out how old his dad is. And again, I can do this, I can do the first, I can do the second. I'm going to do the second because it already has K equals. So 7 plus 4M. So 7 plus 4 times 9. Let's see, that's 36 plus 7 is going to give me 43. So Max is 9. Kirk is 43. All right, so yes, there's a lot of steps, but if you work neatly, they're not hard steps. It's all solving equations from last year and the year before that. All right, any questions? Bring them to class. Have a good night.